So we're going to go one by one through this sheet here. Okay. So this guy gave us some trouble. First off, a lot of you guys were changing this, but then you were losing. Like this became 16, which is neat. Or this became, I don't know, 3/5 or something. This is 3 1/5, so it's certainly bigger than 1. So it can't suddenly become something smaller than 1. So what should it become? 5? 5 times 3 is 15 plus 1, so 16/5. And here, division by this is multiplication by 2. And very quickly, have you ever been shown why that's true? Why, when you divide fractions, you multiply by the reciprocal? No, you just kind of accepted it. You said, what the hell? The rest of this stuff is made up anyway. Why shouldn't I believe that? So let me do a little simpler problem right here real quick. If I had like 3/4 divided by, I don't know, 6/5. You with me? I can write that like this. I normally would not write it like this, but I certainly could. I wouldn't write it like that because now it's a fraction with fractions in it. It's kind of gross. All right? But now, just go with me. I would never, ever do it this way. Never. But it's a good way to see why it works the way it does. How do you make the bottom 1? If the bottom's 1, then the top is the whole thing. You guys kind of with me? If I can make the bottom 1, the top is the answer. How do you make the bottom 1?
Multiply by
the
opposite of 5 over.
So if I multiply by 5, 6. Now, of course, if I do that to the bottom, I better do it to the top. So now on the bottom, this cancels out. So this, which was this, must be equal to this. Kick ass. So, I mean, it's pretty simple once you see it, but you should never accept things on blind faith, especially in mathematics, because it's not supposed to be built on blind faith. And the more you kind of accept things, the more your brain goes, yeah, I'm accepting it. I'll get through your class, but it's all bullshit. You know, that's a horrible way to look at things. All right, so that's why you multiply by the reciprocal. So when you divide by a fraction, multiply by the reciprocal. Here, of course, I need LCD. I just saw a couple of 15/5 show up, and you can see where that came from. 16 minus 1, 5 minus 10. It should be negative if you want to continue down that weird logic trail, but you cannot subtract or add fractions unless they're like terms, which means like denominators. So now I've got to make this. Yeah, so multiply the top by 2. So then I have with 31/10 times 20 over 31. That's really nice. Because what happens? Yeah, the 31s go away. 20 divided by 10 is 2. So the answer is 2. All that mess is 2. All right, cool. To me, that's what I like most about mathematics. Taking this ugly, ugly thing, and it's just this. Oh, good. B.
Wait, how come you did you just cross multiply or something? How did you do that?
Where are we at? Oh.
She was
I
have the same question. Can you do that last
So right here.
Yeah, why did you do that? I never did that.
All right, so this is multiplication, and this bar is division. So these will definitely cancel. They are opposite operations occurring. Anything on the top and the bottom, if they are the same, they can go away because they are being divided by each other.
Oh, okay.
So you could do 31 times 20 and 10 times 31 and get these ugly-ass big numbers that you have to reduce. And that's not the problem I want to do. I'd rather reduce first and then multiply. Then my numbers are small to begin with. So I could multiply. Now go with me. Let's just say I can write that down. But now look, 31 divided by 31 is gone. 20 divided by 10 is 2. So that's really, I'm not cross multiplying or any weird shit like that. All I'm doing is anything on the top can cancel or reduce with anything on the bottom.
That's what I thought you did, and I was like, what?
all I'm doing is cross-dividing, because anything on the top will certainly cancel with anything common on the bottom. Because they are opposite operations then. Sweet. Because I'm multiplying up top, I'm dividing by the stuff on the bottom. 31 divided by 31 goes away. Cool. And really, when we reduce, how do I reduce 35 over 20? Yeah, because 35 is 5 times 7. 20 is 4 times 5. Don't the 5s go away? So if I had 5 fourths times 7 fifths, I'm not going to make it look like that. It's already broken up for me. I can already see the common things that would want to go away. So why would I put them together and then tear them apart again? That's crazy. Just kill what's common already. Huge suggestion from me to you is to reduce first when you're multiplying fractions. Then you have smaller numbers to begin with. That's always good. Okay. B. We all loved this problem. This is our favorite problem. And I'm being a complete ass right now, but order operations, that always frustrates me how much trouble it gives people. But when you get up to 103 level, I am going to be a complete hard ass about this, because it should be no problem by now. Right? And if it is a little bit of a problem, firm it up. Get some help, come see me, go to tutoring, whatever you got to do. I've had students tell me that they were told wrong from other instructors, and sometimes that actually happens. Some instructors look at the M and the D and they say, yeah, you multiply before you divide, and they're the ones that we need to get out of the profession I'm in. They need to go away. What did I say the other day? I'm pretty sure we covered this idea here. Right? It's not, it could have been Pedmasaw and all that kind of crap. You do this as it comes, you do that as it comes. You don't do M before D. They just had to pick a way. They could have put the letters right on top of each other, but then how do you say that? I don't know. All right, so let's not do that. So here, what's the very first thing I have to do?
Parentheses.
Yeah, parentheses. So a lot of you guys are trying to cube first. I can't. For one thing, cubing is based off of, what powers are based on what operation? What operation are powers based on? Multiplying. They will not play well with subtraction. I can't distribute a cube through there. Right? I can't. So I have to do the inside first. In fact, if I had this, can I do the inside first? But can I just say it's x cubed minus 7? No. What do you know you have to do with this? Write it 3 times. Foil. I got to have other ways around it, right? So here I can't just cube 3 and get 27. No, no, no. What number am I cubing?
-2.
-2. Hell, that's a lot easier shit. So when I can do the inside, hell yes I will. If I can't, oh crap, I got more work to do. But dear God, when you can do it, do it. So here I get, so inside here first. Cool. And of course, what's next? You have powers. So of course, if you're not as comfortable with this, you should go strictly by the book. The more comfortable you get, the more you can do several things at once, or be smart about the way you do things. But here, I'm going to go strictly by the book. Cube next. -2 cubed. -8. Because if I have 3 negatives, you got to be careful not to flick you guys up. 2 of them cancel, and 1's left, right? So it's still negative. And now, what's the next thing I do?
Multiply.
I do not have a 3 here, right?
No.
This is 5 minus, I don't know yet. So I can't, the very last thing I'm going to do is the subtraction, because it's way the hell at the bottom of the order operation. So I've got to do that subtraction last. So now here I just go straight through this. This as it comes. 5
Plus 16.
plus 16. 5 plus 2 times 3. 5 plus 6. Now I can finally do this. 5 plus 6. Well, okay, maybe. And why is order operations important? Well, it's important because it's true every damn where. So it will always show up somewhere. Always. Because it's true everywhere. So it could show up at who knows what. There aren't order operation problems and then other kind of problems. There are problems that exist where order operations is true. That's period. Part C, I think I want to make this distinction really clear. Simplify is the opposite of factor. It's the opposite of many things. But one thing it's the opposite of is factor. Factoring is undoing multiplication. Simplify means do all the operations. Second thing about that problem is you can't factor anything in there. Right? You actually can't factor that trinomial. You can't. There are no numbers that multiply to be positive 3 and add to be negative 2. There are none. Okay. Cool. So when I say simplify this, what am I really asking you to do? Yeah, we use that word FOIL. Of course, the word FOIL is funny to me because it only deals with FOIL. This would require some other long, like I don't know what it would be. First, middle, last, intermiddle. Oh my God, screw it. But all I think about is I have two things to distribute. I don't need FOIL. I don't need that. You distribute 2x. You distribute -1. Why do I need some mnemonic device? Now I can make this thing as big as I want, this thing as big as I want, but you just take the first two, distribute, second guy distribute, third guy distribute, and then get all your like terms together. I don't need FOIL. I don't. So what do I get here? Good. 2x cubed minus 4x squared plus 6x minus x squared plus 2x minus 3. And then I can kind of line my like terms up as I go. It's not a bad idea. So you get 2x cubed minus 5x squared plus 8x minus 3. Cool. All right, cool. Yeah. Oh, good. He's untangling his own cords. And then part D. Now, recall. What does a negative power mean? So let's figure it out. Recall, what's x to the 4th divided by x cubed?
4 minus 3.
Yeah, 4 minus 3, so I get x to the 1st, right? And really another way to think of it is 4 x's on top, 3 x's on the bottom, 3 cancel, you have 1 left. Cool. You guys cool with that? So how do I get a negative power then? The bottom power has to be... How do I get a negative? Here I got a positive power, didn't I? Because 4 minus 3 is positive 1. So all I really have to do here is make it x cubed over x4. So let's look at x cubed over x. So let's do this two different ways. 3 minus 4, -1. Now let's do it this way. X, 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 X. I'm glad I didn't make it 8th power. How many x's cancel? 3. How many are left?
1.
Where? So this must be 1 over x. So negative power means flip. Because think about this. How do I, if I have 8x like that, if I had 8, how do you make it 7? If I let you divide this or multiply this or whatever, how do you make it x to the 7th? Divided by x. I love it. I like the way you look at it like, divided by x?
So confident.
I know. I like it. So divided by x. But wouldn't you want, that would be x to the 7th. But couldn't you also multiply it by, what would you add to 8 to make it 7? What would you add to 8? Okay. This is not a proof, but that's evidence that that is the same as that. They both do the same thing. So math says they must be the same thing then. Okay, hopeful. So anything that's to a negative power, if it's on the top, it will go down. If it's on the bottom, it will go up. It just flips. So when you get a problem like this, first off, let the numbers be easy. Numbers easy. You just reduce them like you always would. A few little hiccups on that, but you know, I'm okay with every now and again saying 2 times 3 is 5, as long as you don't believe it, right? But what goes into both? 3, so you get 8 over 5. Now, tell me, which variables want to move?
Minus.
Yeah, so these 6 x's
Bottom.
are going to go down there, and these 7 y's
Top.
going to go there. These guys stay right where they are. They're positive. They're happy where they are.
That's fine.
All right. So now, how many x's will I have down here?
2.
I have 7. How many are coming down?
Plus 6.
6. I have 7 y's up there. How many are coming up?
7.
So now on the top I have 14. On the bottom I have 13. What's up?
I don't know how you got, how you said flip, but it's still 8y to the 7th and then 5x to the 7th?
Totally. Because what tells me to flip? What's the only reason I would flip anything? If it's to a negative power. What are the only things that are to a negative power? These 6 x's. So they went down.
Goes again.
These 7 y's. So they went up.
Oh, okay.
Good. I love it. It's my favorite sound.
So for the 7, you just add the 2 on the bottom instead of subtracting, because that's what I did.
Exactly. Because if you actually apply the rule, it'll still work. What's 7 minus negative 7?
7 plus 7.
7 plus 7, 14. But dear God, that's why I don't do that, because it's so easy to make a negative mistake, especially when you're trying to do it in your head. So a lot of you guys got first powers here, or the y's canceled, right? They can only cancel if it's exactly the same. They're not, so how could they? Hopeful. Yeah.
You mean just the negative, we can flip, just negative?
I love it, because the only thing that means flip is a negative power. Right?
Because I answer y and x to the up. X 13 and y 14.
Okay, I like it.
Correct?
Yeah, but you should have 13 x's on the bottom. If you have like x to the negative 13 up top, it should end up on the bottom. Yeah. Okay.
So when you bring them down, they change the signs, right?
Exactly.
Right.
Otherwise, they would just keep going forever.
Right.
Y negative 7, y negative 7, y negative 7, when would it stop? So if it's unhappy upstairs, it's going to be happy downstairs.
All right.
Right? Yeah.
Well, like x negative 6 is on top. If there was no x on the bottom at all, would it still go to the bottom?
It sure would.
Okay.
And it would just have 6 x's on the bottom. They're going to go down no matter what. There just happens to be 7 already there, so now there's 13. Yeah, so I actually don't even do this. I just go 6 more on 7 is 13. 7 more coming up. There's 7 there already. There's 14 now. Yeah.
How come though when it goes all to 13 instead of to 1? Like when you move it down, you couldn't just make, because it's negative.
Because if it's negative here, when it moves, it becomes positive. Because the negative's done its job.
Okay.
Otherwise, like I said, it would never stop bouncing. It would be like negative for, oh yeah. It's not happy anywhere. Right? So the biggest mistake I see associated with negatives, instead of just forgetting that you have to move them, is if I had something like this, what would that become?
8 multiplied by 1 over x.
Good?
8 over x.
Which is just 8 over x. I like it. The 8 does not go down with the x. The 8 is to what power? Understood 1. It's an understood first power there. It's happy. It's not going to go anywhere. Only the things with a negative power move. Okay. So on the heels of that discussion about negative powers, now we have the next problem, which is 0 powers. Is anybody, any more questions about that? Okay. What the hell does a 0 power mean? So let's figure it out. So earlier we had this was this. And then we said, how do I get a negative power? Well, you put the bigger power on the bottom. Well, how do I get a 0 power? You make both powers the same. Because now 3 minus 3 is 0. But what's something divided by itself? 1. Good. So anything to the 0 power is 1, except for 0. 0 to the 0 is technically free. The true technical term for that is indeterminate. It's worse than undefined. And it's the most I'll say about it in this class. Right? Comes up later. But any other number to the 0 power will be 1. So when you have a problem like this, three to the 0 is
0. Oh, sorry, what?
2 is to the first power. It just stays 2. Times negative 2 to the 0 is 1. Right, it's not negative 1. Any number to the 0 power is 1. So then I get 1 plus 2, 3. So on the heels of that, what would negative 2 to the 0 power be? No.
Negative.
2 to the 0 is 1. And it's got a negative on it. Right? It's the old thing about what's the difference between these two? That is the opposite of 2 to the 0. This is the opposite of 2 raised to the 0 power. Anything to the 0 power is 1. That's the difference. That's that same old thing about this versus this. Remember that? Which one of these is positive? I want somebody to say both of them, but no. Yeah, the top one is positive. The bottom one, 2 squared is 4, with a negative on it. So negative 4, yeah. I lock it. That's basically the powers can only go so far. They can only go right to the thing they're sitting on.
Why is that one not? Again, can you repeat the bottom again?
Let me put it. So if I look at this, how many negative symbols are there? 1. And then 2 squared is 2 times 2. So that's negative 4. But if I write this, how many negative 2's are there? 2. So now how many negatives are there? 2, they cancel. Right. So here I've got 2 2's with a negative sitting out front. Here I have 2 negative 2's, so the negatives cancel. And this really, math is a foreign language. We all know that. So this is really kind of like the grammar of math. And what's the hardest damn thing to learn? Remember way back when? It's a freaking grammar, right? So that's why this is difficult to learn. It's like, where do you put the comma? When is it a semicolon? Oh, shit. Right? I mean, that's really, because I put the 2 there and not parentheses, that means something different. It's exactly like the English language. If you put the comma somewhere else. Anybody ever heard of the book Eats, Shoots, and Leaves? Like, anybody ever heard of that? No. Okay, that's right. So a panda eats shoots and leaves, right? Eats leaves, eats the shoots off the plants. But if you put commas in there, now the panda eats shoots and people and then leaves, right? So commas completely change it. Parentheses completely change the meaning. It completely changes what that's operating on. Grammar, it's the same thing. Maybe. You're like, oh great, Jeff. You just combined the 2 things I hate the most. F went decently well. A few people tried to FOIL that thing out, which is really disgusting. And I know I don't have to FOIL because the operation is subtraction. The big thing here is, what's that negative do? Changes all the signs. So then I get 6w cubed. Here there's nothing there, so I can just take the parentheses away. Here the negative's got to go through. So the 5's cancel, for example. 6 minus 3, 3w cubes. 3w squared, 5w squared, 8w squared, and then I just got a minus 2w sitting there by itself. Is that cool? And then finally on number 1G, this one, I kind of understand. The minute I put something in a different, if it was just that problem, 3x plus 2 minus x. If anybody had trouble with that, I would ask you to leave, right? 3x plus 2 minus x, what would that be? 3x minus x? 2x?
2x.
Plus 2, right? No problem there. Just put your like terms together, right? The minute I put it over that, it kind of makes it, you think it's a different problem, but it's not at all a different problem because these are the same. So it's exactly the same. I just have to add those together. I just have to get like terms together. I just have to put them over x plus 1, not x plus 1 squared. I don't have any x plus 1 squares here. How can you suddenly have some at the end? I'm not multiplying, right? What's 1 7 plus 2 7s is 3 7s, not 3 49s. You don't multiply the 7s. The thing I'm trying to tell you here is variables are numbers. They are numbers I don't know yet. But they have to act exactly the same way as any other number because that's all they are. So whatever I would do with 3 over 7 plus 2 over 7, that of course would be 5 over 7. I've got to do the same damn thing with this. Like terms on the bottom, so it's just that. And on the top, I just add those together. And like you told me earlier, now a lot of you guys got there, but there's one last thing. You've got to see if you can reduce it. Now this problem I couldn't reduce. But that problem, I can reduce. Be really careful. Do not kill your x's, right? You can't cancel these x's. Why not? Because division is not the opposite of addition, right? So I can't break into an addition problem and kill part of it. I have to subtract to kill part of an addition problem. You with me? But I can take a 2 out. Now, division is the opposite of multiplication. It'll eat that up all day long. So those go away. My answer is 2. Now, let's see, just to maybe possibly freak your mind out a little bit. What did I just say earlier about x, of course? We all know x is what? Any number I want, right? Except, in this case, what could x not be? Think about it. It couldn't be -1 because that would make this undefined. So what if x was, oh, I don't know, Jeff, 4? Just go with it. Does this have anything to do with what I asked you to do in that problem? No. This is me going a little further. I will do that a lot. It's really kind of cool to see. If x were 4, what is this?
12.
12? 12 over 5. Plus
2 minus 4.
Which is
2 minus 2.
-2 over
5.
5. You with me? If x were 4, that's what that is. But what did we just prove? No matter what the hell x is, this better come out to be 2. So what do you get here? 12 minus 2? 10 over 5? 2. All right, so any number you pick, except, of course, -1. -1 is the thing that freaks this whole thing to hell, because it makes it undefined.
What about 0?
0 is perfectly fine. Now, when you think 0, what are you really thinking? You can't divide by 0. If I make x 0, am I divided by 0? I'm divided by 1. So if x were 0, what's this?
0.
0 over 1, which is 0, plus 2 minus 0
2.
over 1. Well, 0 plus 2 is 2. Sweet, still 2. So be really careful. Don't just say 0. When I ask you, what makes this a problem? Don't say 0. You're really thinking make the bottom 0. So the bottom is x plus 1. X can't be -1. That's what would make it 0. Cool, cool, cool. Okay. Let's see. What about number 2? So 2 is where we get into factoring. And we will definitely be reviewing factoring. It's at the end of this first bit. I got to always remember I have 2 books in this class. But if you have the white book, it's at the end of the chapter 9 review. If you have the blue book, it's the last part of the homework there in the first section. So number 2A. So whenever you have a trinomial like this, I know it's going to come from the product, possibly, of 2 binomials. Right? And to get x squared, what would I put here and here?
X.
Yeah, we know that when we FOIL stuff like this, we could get something like that if the middle terms are like. I could put that together, right? I know I'm going to end up with a 3-term deal when I multiply 2 things like that. Do the FOIL. So the whole problem now is, what numbers go here and here to make these things work? They got to multiply to be negative 20 and add to be 8. So that would be 10 and 2, and to make it positive 8, the bigger one's positive. That's all. So if it would have been this, so that's the answer there. If it would have been this, the only difference would be, to make negative 8, the bigger one has to be negative. That would be the only difference. I like it. And just to freak your minds out again, same kind of thing here. Because this is really, really cool. X can be anything. In fact, in this expression, X can be absolutely anything. Nothing will make that undefined. In fact, that's a polynomial. Polynomials have to be defined in a way that any X works. That's part of the definition. So give me a number.
4.
4, what the hell? All right. If X is 4, what number is this? 16 plus 32 minus 20. So 48 minus 20, 28. Is that cool? So if X is 4, that's the number that this represents. This expression represents a number. Doesn't look like it because I don't know what X is and I can't put stuff together more than that. But the minute you tell me what X is, that is just a number. What's this going to... Oops, sorry, went too far. What's that going to be then if X is 4?
14.
14? 4 minus 2?
2.
Is that the factoring of 28? One way to factor it? Yes. So why is factoring so difficult? Because when we factor an algebraic expression, we are actually factoring an infinite number of numbers at once. Think about that. What could X be? Anything. So any X you make, this must be a way to factor it. Okay. Maybe it's only impressive to me. I don't know. Yeah, Jeff. All right. But really, really think about what I just said. It's reality. There's an infinite number of things you just did. That sounds like a pretty good morning. How much do you do, eh, Army? You do more than before 9 a.m.? I don't think so. All right. To B, I think most people got this one okay. This is actually sort of the same exact thing as this. I need 2 numbers that, because I know y squared is going to be y. So I need 2 numbers that multiply to 81 and add to be 0, because there is nothing in the middle. Now I'm making it harder than it is, because there's a shortcut to this. This is the difference of squares. So y squared is y, 81 is 9. And of course to make them cancel, plus minus or minus plus. Order doesn't matter because I can multiply whatever order I want to. Cool. And you could do this whole thing to this and we won't. So most of you guys got that one okay. What about 2C, of course? We talked about 2C already. And we did that one in another example. Anybody want to see another cube? Let me do a more difficult one. I like that movie. You guys in the front are like, no, Jeff. Now, first thing is identifying that as a cubes. I can't cut everything in half, can I? And in fact, it's a sum, not a difference. So I couldn't even look at it as a squares anyway. I can't factor a sum of squares. I can only factor a difference of squares. And why is that, by the way? Because the only way to make the middle term cancel is if they are opposite signs. If they are opposite signs, they must multiply to be minus. So I couldn't factor y squared plus 81. Because then these two would have to be the same sign. You can never make the middle term disappear. It won't work. Okay, so what about this weirdness? I know it's a cubes because everything can be broken into 3 parts. 125 is 555. Good, 5 cubed. So 5, 5, 5. W6 is, break it into 3 parts. W squared, W squared, W squared. All you got to do is divide 6 by 3. Right? Break it into 3 parts. So W squared, W squared, W squared. And then this one, 64. Good, 4, 4, 4. And Y9? 3. It's a little bit better to write it like that. Let me write this like that also. Just so you don't forget anybody. So you got 5W squared, 5W squared, 5W squared. You can make this. 4y cubed 3 times to make that. So I got my stuff broken up. Now I just got to put them in the right place. And what is it when I see cubes? What can I put down here to kind of start me off? Little dude, big dude. I like it. So the little dude goes what?
5W.
Yeah, 5w squared.
Plus.
Plus.
Yeah.
So it's always the same thing as that.
4y
4y cubed.
cubed.
So these two have to go here. 5 times 5, 25w, 4. So overall, I still have 3. Right? I mean, it's almost too simple. You break it up into 3 parts, but 1 part there, 2 parts there, 1 part there, 2 parts there. The only dude that doesn't follow the pattern is the middle term, but we need him. He's the cleanup guy. Right? Every time I say that, I think about Pulp Fiction when the wolf comes in. What's the last guy going to be then? He's going to be 16. Y 6, right? So you can kind of keep track as you go. There I got 6 W's. Here I got 9 Y's like I'm supposed to. Right? Do you see that? And what's the middle term going to be? What sign?
Minus.
Minus. He's the cancellation dude, right? The minus. Put those together. 20
Y.
W squared Y cubed. So the thing students miss is that that problem is exactly the same as this problem. They're the same exact problem. There's less crap in here, but I still break it up into 3 parts, put 1 part there, 2 parts there. There's just a little more stuff in all the parts, but it's not a different problem. There's nothing new to memorize. Okay.
Wait, where are you getting 20 from?
5 times 4.
Oh.
So the middle dude is always going to be the product of these guys. Different sign. So 1 of each, 2 of each, product of those. Make a song out of that if you like. I don't normally do that kind of thing. So if you like songs in mathematics, it's too bad. All right. I think we already discussed 3a and 3c. Those are the ones where the x's went away. Maybe we should do them. So I think I did part A. I can't remember now. But part C, let's see, 3c real quick. Okay. Just to save some time, I already did the first step. Cool? Distribute that stuff. Then you get your like terms together. And then here's the step where either people did this. They said, Well, the answer is 12. Or the answer is 8. Some variation of that. And you can see why they did that, maybe. They put the 10 and the 2 together in different ways. But that's not an answer. An answer is x equals something. So once I kind of stress that, people don't want the x to go away. But it's what's going to happen. If I add x to both sides, it goes away. A few people stopped right here. So you're trying to tell me that 10 equals 2. This is not a good thing. Because 10 does not equal 2. Right? If I owed somebody $10,000, I would like 10 to equal 2. Right? But it doesn't. So what is this trying to tell us?
No solution.
Yeah, there's no solution. Now be careful. Don't say undefined. That's got a very specific meaning. You always have to tell me the solution to a problem. So here you must say no solution.
So don't put a 0, just write no solution.
Yeah, or you could do this. You're right. Empty set is fine. That represents the empty set. So if you write the set of all the answers, it's going to be empty. So this symbol here means empty set. Sky, give me a bag with all the answers. So here's an empty bag. All right, thanks. Kind of tells me, okay, give me a bag of all the fish you caught. Basically sums up all my fishing experience. All fishing is sitting around drinking in the middle of the water.
And you can also do subtract 10 from both sides, right?
You certainly could. And it'll still end up with a non-true statement. Oh, that's really all that matters. So you can subtract 2 and get 8. Subtract 10 and get negative 8. But it's still going to be 0 equals some non-zero. Not true, no solution.
Oh, okay.
If this was 2 equals 2, all real numbers. I love it. If it's a true statement, no matter what x is, then you can make x whatever you want it to be. Here, x is not going to save this thing because it died. I can't save it with anything, so there's no answer. Hopeful.
And undefined is 0.
Undefined is specifically, 5 divided by 0. Yeah. There's nothing defined to be that. Then what about 3b? There's a couple different ways to approach this. And to tell you honestly, I'm going to do it a little differently than a lot of you guys tried. If you make all the bottoms 12, that kind of makes sense. Because we know when we have fractions, we want to have like denominators and doing the subtraction and stuff. But then since it's an equation, I can do something really cool that you cannot do if it's not an equation. Namely, I can kill the fractions. Right? I can't do that everywhere. But here, how do I make that the LCD? What's the LCD? 12. Yeah, multiply by 4. Multiply by 2. So then I get 8x over 12 minus 10 over 12 equals x plus 7 over. Now, a few of you guys got here and weren't sure where to go from there. But the really cool thing is, since it's an equation, I can multiply both sides by anything except 0. So if I multiply both sides by 12, that will kick major x. Because then it cancels there, it cancels there, and it cancels there. So then I get 8x minus 10, and that is awesome. Now that's easy to finish, right? Subtract the x, so I get 7x, add the 10, so I get 17, divide by 7, I get a fraction, but I don't care because I'm done. Best place to get a fraction is at the end. Now if you wanted to check it, that would be fun, right? But you're basically done. How are we doing there? Is that bringing back memories? Yeah. And then finally we have number 4, the graphing problem. I'm going to do this 2 different ways. I'm going to do this the way that I intended it to be done, and then I'm going to do it the way that's actually perfectly fine, but it's a little more for this specific problem than you really have to do. This specific problem has really nice intercepts. What the hell does that mean? What's the intercepts? What does that mean? X and Y intercepts. So the x-intercept is where the line hits the x-axis, remarkably enough, and the y-intercept must be where it hits the y-axis. So when I hit the x-axis on a line, what must be true? Y must be 0. Do you guys see that? I can't be up or down at all, so y must be 0. When I hit the y-axis, x must be 0. So for some reason, please, listen to me now. The last math course I took, we were finding intercepts. Now, of course, my equation had like 12 letters in it. But if I wanted to find the w-intercept, I set all the other letters to 0. It's that simple. So I was working in basically 11-dimensional space. Yay! We don't have to worry about it. We have 2-dimensional space, thank God. But if I want the x-intercept, I make y 0. And vice versa. Right? It's that simple. So if I make, to find the x-intercept, make y 0. Now, for some reason, I always get somebody tell me this. But of course, that's 0. So then x is 6. So that is a point. The point 6, 0. Then to find the y-intercept, you make x 0. So that I'm going to make that go away. Divide by -3, I get y equals -4. Is that cool? That's the really nice thing. Bam, 6. Bam, -4. Right? Maybe. If you make x 0, that's the equation. You guys kind of with me? Some of you guys look at me like, I will hurt you later. So 2 times 0. So this becomes 0. Divide by -3. That is a point when x is 0, y is -4. The reason I make a big point of that is some of you guys graph the point 6, -4. It's not one point, it's 2. How many points do you need to graph the line? At least 2. So if you have 1 point, you're like, what the hell do I do? So here I've got 2 points, 6, 0, and 0, -4. And then there's my line. Sweet. And of course, what the hell? Why do we graph things anyway? How many answers have I found? Yes. How many answers have I found to this equation? 2. I found 2 answers. How many answers are there? Infinitely many. So if I ask you to list all the answers to this, right, you have every right to say, no, I don't think I'll do that. But that's actually what this is. This is a visual representation of all the answers. So I found 2 points. By connecting them, I say that every other point that line goes through is also an answer. So this, a graph is the quickest answer to what are the answers, what are the solutions to this equation. That is the most basic reason why we graph things. Right? The next reason we graph things is because very often their shape is useful to know. When I throw a baseball, it goes like that. Right? When I hit a golf ball, it goes like that. Because I don't really play golf, so that's a bad example. When somebody else in here throws a golf ball, maybe it does something neat, and then you need 3 dimensions to kind of define it, maybe, right? But the shape of the graph might tell us something physical about what's going on. Okay. So let's do this. Any questions from that warm-up sheet? Yeah.
On the last one, I did
Oh,
that differently.
that's right. I meant to do it 2 different ways. The other way to do that problem is, of course, to use slope and intercept, right? So if I solve this for y, I'm forcing it into what form? Y equals mx plus b. I love it. So that actually is semi-freaky. Just by solving for y, everything else falls into place. It's kind of nice. So if I solve this for y, what I always do is switch those, divide by 3, so I get y is 2/3 x minus 4. Just solving that thing for y. What's the y-intercept then? It will always be this number because it will always be what I get when I make x 0. You with me? So -4 is the intercept. And what's this telling me to do? Up to over 3. Up to over 3. And if I go up to over 3 again, I get to 6. That's the point that we got there, right? If I go up 2 over 3, up 2 over 3, I end up at 6, 0. That's the other point that I got here. Semi-straight line. Okay, maybe. MX plus B sounds vaguely familiar. All right. So let's do this. We're going to go on our little tour.